which is a multi-step process for some reason. It shouldn't be. If I use my glasses, I'll be able to see better. Okay. It used to not be multi-step, but because I am insisting on using this mode, there. Sometimes I have to move it from one screen to the other. Okay, here we are. So, yeah, so philosophically, yeah, here's our notes from last time. Philosophically, what are we doing? So Jefferson, it minimizes the max, the largest, maybe I should write it down like that, largest district size. So in other words, you're going to take um, the states. If you remember how we did the D'Hondt table, you divide each. You sort of figure out the average district size for each state, and then you pick the one with the largest one to give the next seat to, and then you go that's equivalent to doing Jefferson's method. So it takes the largest district size. That's okay. You're going to have the next seat because you have the largest average district size, and we keep going like that until we get the to that. So that's that Jefferson's philosophy. Oh, we should back up, I guess, because Hamilton, it did minimize something. What it minimized was it minimized the work. I mean, honestly, that's what it does. If you've tried to do Jefferson or Webster, Hamilton's method is the easiest, and so it's always the one. Usually, I know you guys are special, but whenever I teach about this apportionment, Hamilton is the one that everyone comes up with because it's easy to understand. It minimizes the amount of work you do. Jefferson minimizes the largest, like the largest district size. Webster does minimize something. It minimizes the absolute. And you might say, well, how is this different from Jefferson? The absolute difference between largest and smallest district. There we go. So minimize, wait, I think I might have this, well, it doesn't matter. I think I've actually got Jefferson written slightly incorrectly. It doesn't matter because we don't use Jefferson. But Webster's method minimizes the absolute difference between the largest and smallest district. So if you take the state with the largest district size, compare it with the state with the smallest district size, Webster actually minimizes the absolute difference. What does that mean, absolute difference? So if you look at, let's just get this, pull this up here real quick. I'm going to back up and find one that's done in Webster's method. So this is back in activity 12 if you have your book. So let me find, here we go. Here we go. Okay, so if you're looking in your book at page 95, there's actually 94 has a good one. So here, let me show you this. I'll put it up on the screen too for the people who are watching from home, or if you're not. Just a sec. Let's take this picture, and then I can write on it. So what in the world does this mean, minimizing the difference between largest and smallest district size? Just a sec. I want to make this, crop this just a bit. So this is the answer to one of the questions on page 94 using Webster's method. So here's what it means to minimize the absolute difference in district size. So here, district size is 64 over 9. So this is the district size in that state. And I'm going to have to get a calculator because I can't do that in my head. So give me a sec. I'm not going to do all of these, don't worry. 94 divided by, 4464 divided by 9 is 496. So in other words, there are 496 students at Central High School for each representative. And then compare that, well, sticks is the easy one here. Sticks is, there's 422 for each representative. And let's just do one more just to see how this works. This one is 1842 for Hill High divided by 4 is 460, 460.5. So what Webster does is Webster ends up minimizing the absolute difference. So here, the difference between the biggest and the smallest here. I know I didn't do all of them, but let's just pretend that I did, and that this was the biggest, this is the smallest district size. It would minimize the absolute difference. So here it's a difference of 74. So the difference there, absolute difference, is 74. So Hill-Huntington, because of the way the Hill method, the way that it does its thing, so the difference between Hill and Webster is that Webster says if you're above 0.5, you go up. If you're below 0.5, you go down. Hill chooses this weird method of using the geometric mean, and hopefully you got that. We go back to Hill. Find this just to point you to where you should be looking. Where's Hill? Where's paradoxes? Here's Hill. So this was on page, didn't you have to do one of these? Just a sec. 15. I thought there was a table you had to fill out. Geometric mean. Okay, so the geometric mean is, it's on number 5 on page 118. And you can always flip over to the answers because you have the answers. And you'll see those geometric means on page 121 at the top. So anyway, so the Hill method, it rounds up if you're above the geometric mean and down if you're below. One of the properties of Hill is that you're guaranteed that you always have at least one representative because the geometric mean of 0 and 1 is 0. So any number above 0 gets rounded up to 1. And then you'll see that the geometric mean between 1 and 2 is the square root of 2, 1.414. And so that everything gets rounded up if you're above 0.414, rounded down otherwise. So that's Hill's method. But what Hill's method does is it actually minimize the relative difference. Between the largest and smallest district size. And I know it feels like that's the same thing, but that isn't the same thing. And I'm so intrigued by this that I've added I know, this is great. I've added a small assignment that I'm hoping you'll help me with this because, I mean, I could do this myself, but I thought, why should I do all the work when you guys could do it too? So I'll explain that in a bit. But there's this connection between these two that I'm really intrigued about that I'd like to investigate further. It'll take some work, but if we all share the burden, it'll be fine. It'll be easy. So anyway, minimize the relative difference between the largest and smallest. And just to show you what that means, what is relative difference? Well, 74 is the absolute difference. Sorry, it looks so funny there. I'll make that into something that looks better. It's a 74. So that's the absolute difference. The relative difference is the percentage difference between these two numbers. Usually what you do is you take the difference and divide by the smaller number. That gives you how much bigger the big number is. So in this case, 74 divided by 422 is 17.5%. So this is 17.5% of 422. And it feels like that should be the same, that if you minimize this number, you'll be minimizing that number. But interestingly, it's not exactly the same. And so anyway, that accounts for the minor. It's just a slight difference between those two. And it intrigues me is how to visualize that difference. So anyway, that's my summary that I wanted to at least least summarize what we're doing, is that you're always trying to optimize or minimize something. You want to, that's what each of these people do. Adams even was trying to optimize or minimize something. And so we can talk about that maybe after we do our little project that I've got. Okay, so 15, no questions about Hill. Hill is the most complicated. At least I think it is. But it's doable, especially if you have a calculator and you guys understand what the square root key is. Whenever I do the square root, like whenever I do Hill with the freshmen or the math systems, it's like it blows their minds. Like, oh, what is this? Why are we rounding in this way? So you guys are fine. Okay, so let's see, move on. There was a little historical blurb, wasn't there? Let's see, what is, oh, no. This is the difference, yes. Choosing a method, mathematics or politics. Of course, I always lean towards mathematics whenever I think that whenever we should make decisions as a country, we should lean towards mathematics rather than towards politics. The difference, by the way, is are we going to do what benefits our political party, or are we going to do what is best for the entire population? At least that's the way I feel about it. So, for example, things like issue 1 that's on the state ballot, I'll be voting for that, despite the fact that I'm a registered Republican, and it seems like all Republicans hate issue 1 because the state has failed to redistrict fairly. Let's try something different, right? Let's have an independent group try to redistrict our state. So I'm happy to vote for that because I feel like that takes politics out of it. Because each time the politicians have tried to redistrict our state, it's gone poorly, at least over the past couple of decades. So anyway, that's what this I think is all about. I don't know. Does anyone else have anything that they thought of? I don't know. That was kind of not really related. The issue 1 is only peripherally related to this because redistricting is related to apportionment, but only peripherally. But did anything pop out at you when you read that over that you'd like to talk about? And if this was an English class, you guys would all be blabbing all the way, right? You're used to math. It's like, why do we have to talk? All right, because I haven't called on you, right? Well, yeah, it has some examples in here of various things. Like there's a failure to apportion the Congress in 1920. I had mentioned earlier the failure of 1880, which isn't written in here, but you know the politicians have a hard time. 1880 is a great example of the politicians saying, we don't care what the mathematicians say, we're just going to do whatever we want and apportion this in some illogical way that only benefits our party. So, yeah, anyway, let's go on. Quota method. So quota method, this is intriguing to me. I had never, before reading this book, I'd never seen this method. So this isn't commonly covered in other books. So just an interesting method that says that it avoids the quota issues. So you have quota issues, which is to say that all the quota methods, Hill-Huntington included, Webster, Jefferson, Adams, all of them can violate what's called the quota condition, which is you should never have more than your upper quota or your lower quota. That is your ideal quota rounded up or down. That's what you should have. And each method could violate, you can come up with some crazy example which would violate it. And this quota method is intriguing to me because it avoids that, supposedly, and it avoids the Alabama paradox, which is all the problems with the Hamilton's method, which is why even though Hamilton is easy, it's not used nowadays because of all of its problems, these so-called paradoxes. So anyway, I know you only had to do a few, let's see, where are we doing? 1 through 8. I guess that's almost all of them, right? But what did you think about the quota method? Did you have any questions or anything that didn't work for you or you didn't understand how it worked? So you could go over one of the problems if need be. Or not. Yeah, so you'll notice that the quota method, we're minimizing, what are we trying to minimize? We're minimizing the possibility of having, these problems. We're trying to avoid the problems of the Alabama paradox, as well as violating the quota condition. So I guess that's what they're minimizing. So we use Hill-Huntington nowadays. So that's at least until Congress decides to change the law. The law was set in 1945, I'm going to say. 42, whatever. It was back in the 40s. And set with the house size was fixed, as well as the district size, or the method. Method was fixed with Hill. All right, well, this is proving to be shorter than I thought. So no comments or like anything, any comments about like contrasting all these methods? All right, well, let's see. I have a job for you. Let's go over the things. Well, here, before we do that, let's go back. Okay, so today you're going to give me this stuff. Great. Okay, so I have a job for you, so we're not done. I just want to review this because I need to show you this. So the MFT, we talked about this already. I'd like you to do it the week of November 4th through the 8th. This means, wait. Oh yeah, November 5th, no class. So 4th through the 8th, sometime during that week, I don't care when. You can do it anytime from 8 to 4:30. You pick a time. And if you are having trouble picking a time, you could always pick the time that we meet, because on November 5th, at least, we aren't going to meet. You might wonder, well, why are we not meeting on this day? Why not make it November 7th? Well, it's a personal preference for me, but also on November 7th. Hopefully, most of you will have taken this, and so we'll have some chance to discuss how things went. Because I have a secondary job for you. I think I'd mentioned this, that every year that I have you do this or have students do this, I have them tell me about their experiences. So I have on, is this it? Yeah, this is it. Let me pull this so it's separate. Give me a sec. On our Moodle page, I finally added some stuff. I still have to clean up a few things on our Moodle page. It's pretty bad. Okay, so move this down and zoom in. Give me a sec. Zoom in. Plus. There we go. That's better. Oh, look, my big fat face up there. Okay, so there's two things that are new here. We'll talk about this apportionment Excel sheet in a minute. First of all, though, since we're talking about MFT reflection paper, you're going to take the MFT sometime during that week, and then by Tuesday. So Tuesday, this is the Tuesday following. You're going to submit reflection paper, pretty straightforward. I've got some questions for you, though, to help focus, because you might say, well, what am I reflecting on? You know, it was the most horrible test I've ever taken. And some people say that. But here's what I'm curious about is, let's see, it's so big. Oh, come on, where's the thing? I had, what in the world? Sorry, I had zoom out. I had written stuff. Oh, let me see. Maybe it got stuck somewhere else. Give me a sec. It's got to be here somewhere. I'd written explanation. Oh, there it is. Why is it not showing up? This is the activity instructions. Wouldn't the instructions be on the activity? Let's see. I don't understand this. It's this new Moodle. It used to be so easy. Now it's, what is that? Box content top. Reading summary. Where's the activity instructions? Okay, I'm going to go back. I'll just change it to description. I'll move that junk to, well, it's good for me, I guess, to check this. I'll put it up here. That way you'll be able to find it somewhere. Okay, let me copy this, shove it up here. There we go. Cranking there. Okay, let's try again. Let's view it. Okay, sorry, save and display. I don't know why the instruction, you would think the instructions would show up. Maybe they'll show up for you, not for me. Okay, well, here it is. Here's the, maybe it's just a summary. Yeah, where would instructions go? I'll have to ask people in the Moodle gods, the Moodle priests, the high priest of Moodle will help me. But anyway, getting back to this. So here's the instructions. I say 1 to 2 pages. I'm really not expecting much more than 1, to be honest. I just put 1 to 2 because I'd rather not have 0. And if I say 0 to 1, then 0 is an option, right? So 1 to 2, you know, fill up a page. It's easy. So tell me about, here's what you're going to tell me about. Tell me about the MFT. What do you, so you're saying, well, what do you want me to tell you? Okay. What topics did you see? You might say, well, I don't remember. You must have remembered something. So after you take it, you might jot down a few things. So tell me things that you saw. Was there anything that was easy? Like you had a bunch of basic algebra stuff or basic arithmetic. Was there some hard stuff? You know, how do you think you did? You might tell me about topics that we didn't even cover. You'd be like, well, there was this crazy thing. It was talking about some sort of a topological space, and I didn't even know what those words meant. So yeah, tell me about that. You know, you can tell me that it was terrible if you want. I don't care. I mean, some people do. So how do you think you did? Did you bomb it? Did you do okay? And remember that my bar is pretty low for this. You know, in terms of the percentile that you get. You get in the 50th percentile, I am thrilled. I am thrilled if you get 50th percentile. Seriously. And I don't know what that means in terms of number of problems correct, because it's a percentile. It's not an actual raw score. So, but how do you think you did? And we'll contrast this. So after you tell me how you think you did, maybe even give me an estimate of your percentile. Like say, I probably was in the 5th percentile. Fine, tell me that, and then when I get the score report, I'll give it to you. We can compare. You know, maybe you did better than you thought, or maybe you did worse. So how do you suggest we help students do better on the MFT? And then finally, as I was writing that question, I thought, you know, maybe it doesn't even matter. Is this important? Is it important to do well on the MFT? Why or why not? You know, so, you know, just a few questions. You don't have to answer. Well, you know, this just gives you some structure, because you might say, how do I reflect on my experience with the MFT? Well, this will give you some places. You can go further than this if you want. Tell me more if you want. I don't know. You could, up until this year, I think this is the first year, I think up until this year, we've had as a graduation requirement that students take some sort of a culminating test like this, every department. So for example, education, you had to take the OAE was required to graduate. You don't have to pass, you just have to take it. This year, I think we've dropped that as a graduation requirement for some reason. I don't know why. I must have heard reasons, because I probably voted. This probably went through the faculty assembly, but honestly, I can't remember. So I think going forward, we don't even have to do this anymore. But I thought, well, we'll do it this year because we've been doing it. And then, you know, if you think it's completely a waste, let me know. We could always have you do another test. I mean, we could focus more on the OAE, for example. I try to do a little bit of that in here. But, and it's hard to schedule, like, and if you're not a teacher, you don't care about OAE. So that's the history of this. The MFT, it's been used for decades, since before I came here. So that's 28 years ago. We've been using the MFT to evaluate our students. Maybe moving forward, we don't need it. Maybe we do. But just curious to see your thoughts. Okay, so that's that. Okay, final thing, which is going to take a few minutes, so don't pack up. Let's go back. You might have noticed, you saw maybe peeking out above this. Where is it? Go back to the course. And this, I guess I need to, whoops, I may need to update this as well. Under assignments, I have another assignment. And oh, by the way, MFT reflection paper is due the Tuesday after. Now, Tuesday at 12 a.m. I think that effectively that means it's due Monday, right? If it says 12 a.m. on Tuesday, that means better get it done by Monday. The Monday after the week that you're going to do the MFT. Might as well do it right after you do the MFT though. So, so just to warn you. Okay, the other thing is I was getting ready for today's lesson. I was wishing that I had some way of comparing all of the methods easily. Let me show you what I mean. So for years, I've used a spreadsheet that looks like this. There we go. This is horrible, but here's what it looks like. So here's my spreadsheet that I use, and I'll modify it each time I need to. I've actually yeah, I call it speedy apportionment. I don't know if you can see up there my whoops, my the title. There it is, speedy apportionment. But anyway, let me get that zoom off. So what it is it just has, it's terribly written here. And this morning I thought I need to update this. Actually, this morning I was doing this. And so what this is these here are the states. Here, I'll just do that, change the color so you can see. So these A, B, C, D are the various states. And then this is the size of the house. And then these things are the ideal quotas. Wait, are they ideal quotas? What did I do here? Yeah, that's ideal quota. This is the divisor. You can sort of recognize the formula here. Total population, divisor, and so on. I've got some other junk here. I don't even know what this is because each time I use it, I just save what I've done, and then I forget about it till the next time I use it. So you'll notice that for this particular, I've got this set up to be Jefferson's method. So here I've rounded everything down. Whoops, there we go. So Jefferson's method, this is using the standard divisor. Here's using this, oh, yeah. So I didn't apportion enough seats with 36,600. So I rounded everything down with 36,000, sorry. Yeah, 36,000. Tried again. My total was only 24. I'm looking for 25. And sadly, with this particular, because of the numbers, there is no way to do Jefferson's method. This happens every now and then with Jefferson, is that if you have your numbers, and this never happens in real life, because in real life, there's not going to be 400,000 people. There'll be 400,003 or something like that. So the numbers won't work out this perfectly. But you can try all you want with this particular example. You will never get Jefferson's method to work. Check it out. You might say, well, look, 35,999, that divisor doesn't work. You get too many. So I need something bigger than that, but smaller than this. So let's split the difference. Okay, we can do that. I did this morning, and I was like, oh, crud. And it still is 26. And by the way, you might say, well, are those numbers dynamic? They are. If I change this to 34,000, it changes those. So basically, I've divided and rounded down. So each one of these. So anyway, this is my really cheesy spreadsheet attempt. So this morning, as I was getting ready, drinking my coffee, I thought, you know, I could make it look better. And so I came up with, or I started, just a minute. Where is it? Oh, yeah. I started twice, apparently. Here's attempt number 1. That's as far as I got. Wait. Is that as far as I got? Yeah, I don't know what I was thinking. I have 2 of these. Here's my other attempt. It doesn't look much different. So what's going on here? Here, let's get this one zoomed in too. So I don't even have the state labels here. So here's what I thought that we can do. You can help me out with this. So, so this is not due until December 1st, not until after Thanksgiving. So we have time to talk about it because you're going to start this and you're going to say, I don't know how to use Excel. Most of you, I hope, know how to use Excel. It's a great tool for teachers. It's a great tool for other, if you're finance or whatever. It's good to know how to use Excel. So if you don't know how to use Excel, we can work on this. So bring your questions and your cries for mercy next Tuesday after you've started this. So you want to start this, even though it's not due until December, start it while it's fresh in your mind. So here's the job that I have for you. Let's see if this one shows up. Probably not. Yeah, where is the, yeah, there's no instructions. Give me a sec. Let me do the settings, copy this. I'm going to have to ask my people, why is it? Copy, paste it up here. Paste it. And we can work together with this. Here we go. I'll explain why I'm doing it the way I'm doing it in just a minute. Save and display. Okay, let me turn this thing off so that it won't. There we go. There, okay, so we want a spreadsheet with 3 tabs. Hamilton's method, that's the easy one. You'll be able to do that with a spreadsheet easily. And so basically, I just want you to implement each of these methods in its own tab. So Hamilton's method, you will implement Hamilton's method. And I've got a reason that I want to do this. I'll explain in a minute what my goal is. But the instructions, Hamilton's method in its own tab, have it implemented. And Webster's in its own tab, have it implemented. And if you start it this weekend, then on Tuesday, you can come and say, I don't know how to have Excel add the extra seat. You know Hamilton's method? Round everyone down, add the extra seats. Maybe you don't know how to get it to add the extra seats. I can help you with that because I've done Hamilton's method before. And as you saw, I did Jefferson's method. Webster's method is similarly easy to implement. So come up with some implementation of Webster's method, and come up with Hill's method is going to be a little bit more challenging. So that may take some group work and thinking about it, but I want you to get started on it yourself so that I can see how I need to help you. So you're going to implement those 3 methods, and then as sort of a test, just so that we all have the same stuff, you're going to apportion these representatives to these 5 states. So I've got those states. So you can even copy the way I'm going to do here. Let's see, can I copy these and paste them? Let me see if I can paste them into my spreadsheet here. Oh, I did. Yeah, great. Okay, there. Very nice. So here, this would be like the very first step is to get your numbers here. I guess I would want to go down here and label this as, let's see, I'm going to change this to rename it as, this is going to be Hamilton. Great. And then I'll have another one that you'll label as Webster, and then the third one will be labeled as Hill. So anyway, we'll all start with the same sort of same place. So you'll have these states, these populations, and then let me get rid of the zoom. It's somewhere, somehow, and I don't want to. So I guess I'm being a little bit vague because I'm not sure that my way of doing this in Excel is the best way. So I can certainly help you on Tuesday, but I'm not sure that what I want to do, what I think is best, somewhere. So basically, you start with this. You've got the states, you've got the populations. Obviously, you're going to need the total population. You probably want to put ideal quotas in here somewhere, which would be just each population divided by the standard divisor. How many? Oh, 30, right? So maybe down here I'll put number of seats that we're going to be apportioning is 30. I'll even do this for you because I don't think that this is really going to bias you one way or another. So there's my total. Oh, sorry. I don't know Excel apparently. Sorry, I just realized it's not total. It's sum. Someone here was like looking at that thinking that's not going to work. There it is. So there's the total. So yeah, I picked, by the way, I picked numbers sort of randomly. I know they weren't really random because I was just typing on my keyboard, picked, semi-random numbers, so that we wouldn't have that problem with Jefferson, and also so that Excel is probably the best way to use, or one way, using a computer is the best way to apportion this. So this one will do Hamilton's method, then Webster, and then Hill Huntington. Okay, so here's the reason why I'm interested in this is I was trying to, when I was getting ready for today, I was trying to come up with, where's my list here? Here we go. Where's my, there it is. Here. Here's what I'm really interested in. You don't have to figure this one out. Just doing this job for me will really help me. But what I'm really interested in is the difference. So what's the difference? What's the difference? And in particular difference. So this is a big question, like what's the big difference between these two? It seems like they're almost the same. And so in particular, I will, if you guys come up with a better way of doing Hill, Huntington, and Webster than I will use your method, or I might have to rely on my own method, which is kind of painful and clunky. But I want to come up with an apportionment of, say, 5 states where Webster and Hill give different apportionments. So that in the future, I mean, I could do it here as well, but in the future, I'll be able to say, look, here's an apportionment, here's Webster's method. Look, it minimizes the absolute difference between largest and smallest district size. And same problem using Hill gives you a different apportionment, and that minimizes the relative difference between largest and smallest district size, and show the actual differences there. So that's my ultimate goal. And then a secondary goal is hoping that you'll come up with something less clunky than what I have, what I've been using for the past however many years. I've been using Excel to make up, like I use it anytime I have to make a test, or anytime I have to come, so like for example, I guess we have to have a test in here sometime, because I promised you 2 tests. What a pain. So sometime it'll be an easy one, just like the first one. But I'll probably use, if we don't come up with something better, in order to come up with the problems, I'll just use this spreadsheet again to make up some problems that, I'll be like, well, this looks like this one is not a good example for a test, because if I put this on the test, it has no solution for Jefferson's method. So that's the sort of thing that I'm looking for, is a better way of doing it than what I've been doing in the past, and I'm really interested in the difference between Webster and Hill. All right, so let me pause, because I know that anytime I throw a computer problem into this class in the past, not this particular class, but in the past, it always is like, oh no, it's scary, because some people love computers and some people are terrified for whatever reason, even though you guys are digital natives. So what sorts of questions, do you have any worries or fears or anything you're like, you don't even know where to start? Wow, you guys are so talkative today. Loving it. So you got an idea of where you might start? So I mean, the way I would, like I said, I've got my own way, and I don't want to taint your ideas, because some of you probably will come up with something different from the way I've been doing it in the past. But so the way I did it in the past, I won't give you all the details, because I mean, it's pretty straightforward though, is to get Hamilton's method, I would do some calculations in several columns, but you might be able to condense it into a single column. So I'd have several columns, and then at the end, it would spit out, here's the apportionment according to Hamilton's method. You might be able to do it in one column. That would be amazing. But you know the calculations for Hamilton's method. Jefferson is a little bit harder. What I would love, by the way, is when you get it. So here, let me just copy this. So this is my Hamilton's method. And then let's go down here and change to the next sheet. If I can only find my mouse, paste this junk in here. So then you'll have the same starting point for each of the methods. What I would love is for Webster's method, for you to have just one column. You get the apportionment is right there, embedded in your calculations. That would be incredible. But I always have to have multiple columns for Webster's method. But I think that you probably could do it in one column, but I don't know. So be curious to see what you guys come up with. So whatever it takes, maybe you'll have 100 columns, whatever. Oh yeah, you could. You know what? You could just have like a whole bunch of columns and then condense it down. Yeah, okay, never mind. I don't want to, like I said, I don't want to taint the thing, how you're going to do this, because there's different ways. All right, so you know what you're doing over the next week? You're going to schedule yourself for the test center sometime during the week of the 4th through the 8th. They've already told me that that's fine. Whenever is great, just between 8 and 4:30. There's no class next Thursday, So that's the 31st. That way you can get ready and carve your pumpkin for Halloween if that's what you do. And then you've got this additional assignment and then the MFT paper. Hopefully by next Tuesday, that's the 29th, we do have class on the 29th. You'll have looked over this and you'll have some questions, and you might say, I don't know how to do this in Excel or that in Excel. We can work together, get your problems solved for that part. And then also by next Tuesday, my job is to have figured out the next test. You know how I said that we'd have 2 tests. So the second test, it'll be an easy one. It'll have apportionment. Hopefully by then I'll have a practice test and I'll have a schedule as to when that next test is. Probably it'll be whatever, the week after the 8th. So not the 7th, probably the 14th of November would be my guess. But we'll deal with that next week. So Tuesday. All right, look at this. We're done a few minutes early. If you want to stick around and talk, I know you probably don't. You want to go back to bed. So.